Today we're inspecting and testing a 50cc two-stroke kit for a motorized bike. I've always been fascinated to see just how small you can go with these little motors and still propel a human being. Visually, they look identical to a 66, and without a side-by-side, the untrained eye is going to have a hard time telling the difference. The bottom end appears to be identical to a 66, and with a few modifications, could be made to accept a 47mm cylinder. So if you happen to get one of these small kits, fear not, because there's a good chance you can adapt it with a few basic tools. Upon initial inspection, removing the head shows there's no squish band, which sucks because squish is important for performance. And the overspray is going to be a headache later in the video. The head gasket looks like it was ripped straight off a 66. They didn't even bother to match it to the bore, which means there's a gap between the cylinder and the head. And that's not squish gap, that's just a loss of compression. For now we'll use the stock gasket, but later on I'll make my own. I purchased the black kit because it was going to match the bike we're putting it on, but in hindsight that was a bad idea. If you want a kit that's painted, paint it yourself, because the way they do it from the factory is just terrible. Anyways, we measured the stroke, and it appears to be just shy of 40mm, which is kind of confusing because it's a low-hole piston. So either I don't know how to measure stroke, or it's almost a 40mm stroke. One thing I noticed right away when trying to turn over the motor, though, is I could not do it by hand. This motor was super stiff, even with the head removed, which is concerning. Now, normally it's tricky to turn over a motor with your fingers using the sprocket, but I've always been able to do it. On this kit, I had to use a tool. So let's go ahead and get this jug off so we can get a closer look at what's going on inside. I'll often find new builders seeking out these 49cc kits for legal reasons, but what they don't understand is in a lot of states they also require the motor to be marked. There's no marking anywhere on this kit to prove its CC rating, so if you're going to mark it yourself, you might as well do it with the larger motor and take advantage of more power. Visually, there's no way to tell the difference and prove the CC rating between these two kits, and unless a police officer comes out with a pair of calipers and a ratchet, you're fine. They're not going to remove your head during a traffic stop. That would compromise the integrity of the motor, probably also require a warrant. Let's be practical. Anyways, if you do want to adapt this to a 47mm cylinder, I only see a few things holding you back. The stud spacing is off. I would deal with this by removing the studs, filling the holes with JB Weld, and re-drilling and tapping them for new stud spacing. You'd also have to remove some material on the bottom end around the skirt to fit. The skirt on a PK80 measures just over 50mm, and the skirt spacing on our bottom end here is just under 50mm, so you wouldn't have to remove much material to adapt it to the larger jug. Measuring the diameter of our piston gives us 39.7mm, and if you punch this into a displacement calculator along with the 40mm stroke, you get 49.51 cc's. I actually can think of a few legitimate reasons why somebody would want to purchase one of these kits that have nothing to do with legality. We'll get into that throughout the video. Examining the jug closely shows it's free of casting flakes and no garbage I need to clean up. That's nice. But the ports aren't perfect, and we're going to widen that exhaust a bit. One big thing I noticed on this motor is everything's greased. Well, almost everything. We'll see that they neglected one important thing, but every single manufacturer I've seen is neglecting these. The clutch cam, the bucking bar bearing, the bevel gears, the needle bearings, piston, rings, it was all greased, which is really nice to see. This kit came in at about $110 from Amazon with free shipping, link in the description. In my opinion, $100 is the top end you'd want to spend for a 50cc kit, but for that extra $10 we were getting a lot of upgrades that I did not expect. 8mm mounting studs, a wider mounting point for more modern bikes, all hex screws for the case hardware, and a hex bolt for the small bevel gear, which is great because if you've ever stripped out one of the flathead bevel gear screws, you know what a headache that is. The clutch on this actually looks really good too. Nice pads, nice gears, the bearing looks good. I'm pointing out this little wiggle in this pin because a commenter on the Discord server was asking about it. That's completely normal. All the Woodruff keys were well seated into the shafts. Taking them out was relatively easy, but they're a snug fit, so putting them back in means you're probably going to have to do a little bit of light sanding on the keys to get them to slide back in. Now, if you ever lose, damage, strip out, or break a key, I'll leave a link in the description to where you can get 200 of these for $10 and never worry about Woodruff keys again. A few minutes ago, you'll remember that we said there was one important part that these manufacturers always seem to neglect when it's time to grease the components: the crankcase seals. For some reason, manufacturers never grease these, and they become damaged during installation. The sharp edges of the case and the crank shave off bits of rubber. Now, usually, these are thick enough, they'll still work. But this is unnecessary damage. These need to be greased when they're installed to prevent things like air leaks, oil building up inside these covers, or just a loss of crankcase pressure. They even went as far as to grease the bolts for the case to prevent them from becoming seized. So why couldn't they grease the seals? It doesn't make any sense. Oh well, let's move on. On our motor, I noticed there's 2 case gaskets. I've never seen this before, but I think I know why, and it has to do with the painted case. I'll explain more once we crack it open and try and put it back together. Of all the cases I've split, including new and used motors, this was by far the most stubborn. It really required some persuading to get it split. Again, I believe this has to do with the overspray paint job on this stupid motor. As I'll repeat something I said earlier in the video. If you want a painted motor, paint it yourself. Do not purchase one of these pre-painted motors. They are such a headache. Once we finally got the case split, I first inspected the clutch assembly, and sure enough, the pin's dislodged. It's a good thing we checked this because it would have been a major headache that we've had to deal with before. I have a video on how to fix this, so I'll leave a link in the description in case you run into the same issue. But basically, the pin is inserted on one side and slipped out of the other, causing the collar to be crooked. Now our kit is using one of these nice fat nuts for the magneto side of the crank, which is a good thing because in our case we had to use it to persuade the crank out of the case because it was press fit so hard into the bearing. Upon removing the crank, we can see there's no shims, which is always nice because then you don't have to worry about losing them or forgetting how many go on which side. But here we can start talking about why this overspray is such a headache. You see, in the factory, they spray the entire case inside and out before they install any of the parts. And the problem is, once they go to press the bearings in place, it scrapes the paint down the wall and builds up underneath the bearing, preventing them from fully seating into the case. Which is why not only did they have to use 2 case gaskets to get it to seal, but why the engine is so stiff. The bearings are pushing up against the crank and the case so hard that the motor is very stiff, and this is obviously going to cause bearing damage over time. Now for now, I'm just going to run it like it is and see what happens, but this is not ideal. Here I'm covering the crank bearings with some tape to prevent metal shavings from getting into them. Once you get metal in these, it's almost impossible to get it out. Now we're going to do some port matching for the transfers from the case to the cylinder. It's really poorly matched as is. There's a giant lip from the case which would create turbulence, but I'm only going to remove as much material as is necessary to give a smooth transition, because the more material you remove from the transfers increases crank case volume, which reduces pressure. These already have crappy pressure as is, so we don't want to make it any worse. Aside from the clutch pin being unseated, the overspray on the case, and the lack of grease on the seals, I'm actually impressed with this kit for the price. The quality of hardware is really nice. Had I gotten the unpainted model, that would have been the way to go. Alright, let's move on to some port work. To template the transfers for a smooth transition, I put a bit of oil on the base of the cylinder and then push it up against the case. This will leave an outline which you can then etch with a sharp edge. In my case, I'll just use a pick. For cutting these transfers, I'll use a fat carbide bit that bevels down to a fine tip, which will pretty much do the matching for me without removing excessive material. I'll leave a link in the description to where you can find these. They're relatively cheap on Amazon and they cut through aluminum like butter. I really like these sharp bits because you can use them with a low-powered, quiet Dremel tool, which is just so much more convenient and easier to control than my full-size, loud, obnoxious one. Make sure you wear a mask. You don't want to breathe in aluminum dust, and wear glasses, because if you get one of these metal flakes in your eye, well, you're going to need to flush out your eye. Do not rub, because if you rub, you're going to the hospital. That happened to one of my viewers. He said it was incredibly painful. After matching the base gasket to the new transfers, we went ahead and lightly sanded the edges of the piston rings. This conditioning is something I've been doing ever since I saw Rob do it back in one of his videos when Zeda Motorsports was still a channel. I honestly don't know if it helps or if it hurts, but ever since I've been doing it, I haven't chipped the lining off of any of my cylinders, so there's that. Now next we check for squish clearance, which this motor does not have. I was able to fold a piece of solder on top of itself several times and still not get a squish measurement. So compression on this is going to be like really bad. And keep in mind, that's with one base and one head gasket. I noticed the piston's ramped or beveled or whatever you want to call it, so that's definitely not helping. On the plus side, I guess I could deck the head and maybe get some squish. I don't know, there's a lot of room in this dome, so there's no telling how far we could go. I'll leave a link in the description to a website which can give you guys some useful information if you want to dig deeper into porting and power enhancements for motors. I'll also leave a link to a YouTube channel for an individual who's been answering all the questions I have about port work on two-stroke motors. He can really help you out. Now, I've still got a lot to learn, so I'm not going to throw any numbers at you guys. I'll probably just lead you astray. What I can tell is the intake and transfers on this cylinder are spot on for its intended power range. The exhaust is decent as far as its timing, however it could use some widening. We widened the exhaust, but we also lifted it. I wasn't thinking too much about this when I did it. Lifting the exhaust on a standard 66 motor is usually a good idea because it almost always gives you some power gains. Those motors have just enough power to get into the RPMs to take advantage of lifting the exhaust slightly. Unfortunately, the 49cc doesn't really have the power to get to that RPM range to take advantage of it, so I think lifting the exhaust for us actually hurt us, whereas widening it would have probably been the better option. Well, lesson learned. Anyways, the cylinders and piston kits for these motors are $20 on Amazon, so I'm not too worried. I'm just going to order another one and try again, leaving the stock exhaust where it is, but just widening it a bit. Using carbide bits to cut through the lining of the cylinder can be tricky as they like to grab and chip away portions of the lining, which is definitely not good. For me, I will be using a carbide bit, but on a medium speed, and I'll be using one with a fine tip. Any portion of the cylinder that's exposed to the lining, I'll use the tip to slowly cut as to reduce the chance of it grabbing and chipping away the lining. This worked for me, so it'll probably work for you too. But don't get carried away using the fat edge of your bit on the lining sections. After the Dremel work was complete, I used some 320 grit and then followed it up with some 600 grit on the edges of all the ports to reduce any chances of the lining chipping away over time. Here you can see how easily and free the crank is supposed to move on one of these kits and how stiff it is on our 49. It's really hard to move. This is going to rob us of a lot of power. I'll deal with it later by removing the bearings, shaving away all the excess overspray, and putting it back together, but for now we're just going to run it like this. The cylinder port work came out pretty good. I didn't spend a lot of time trying to polish it up because I don't know how this is going to perform. So we're just going to leave it as is and get it back together. Now we got a few things to do before we can put it on the bike. I'm facing the edges of the intake manifold and I'm cleaning it out because, well, it's pretty rough in there. Not well matched, as is common with these intakes. One thing I forgot to do while the cylinder was off the bike is face the intake side. I don't find this always necessary, but it definitely can't hurt, as you can get a better seal when removing the excess overspray and the rough edges. Now I filled the space with a paper towel and some grease so metal shavings can't work their way into the motor. Luckily for us, the intake manifold was closely matched to the port of the cylinder itself. We just had to do a little bit of work to get a nice smooth transition. Now before I could mount it to the frame, this does have the wider lower mount, but it wasn't quite as wide as something like a 4040. I shaved a little bit of material off of this until I could get a nice flush mount onto the bike. This would prevent it from pinching the frame and causing fatigue cracks over time. I'll be damned. I've never seen this before. This is the first carburetor in a kit I've ever got that actually includes its own O-ring. Upon starting it up for the first time, it feels like it's under load, which I just assume is because there's so much resistance on that crank. This poor little 49cc has to work hard just to idle, but it does idle okay. Fires right up, and it runs okay. Now, during the recording of this video was all done during break-in when this thing had basically no power. It's gotten a little more power since I've made this video, but let's show you the first test ride. So what I've noticed riding this bike. The biggest advantage that the larger 66 kits have over something like this is their price to performance ratio. The extra 7mm in the piston is a huge difference when it comes to power. This is literally our first ride on the bike, and you might think it's decent at a glance, until I tell you it's pinned at full throttle all the time just to go on a straight level surface. I had to break in this motor with full throttle because it was the only way to get the bike to move, not because I was being careless. I didn't have a choice. Without significant modifications, I don't think these 49cc two-stroke kits have the price to performance ratio of the larger kits. So that's something to keep in mind. However, over the past few days of riding it, it has gained a little more power, so it can conquer slight inclines, like what you're about to see right here. On most of my other kits, conquering a hill like that is nothing but a brush on the shoulder, and never have to hit full throttle even during the break-in period to go up an incline. It's not the same on this. Now, after break-in is well over with, we have some modifications to try, such as modding the exhaust, putting on a proper head gasket that matches the cylinder, and trying the lower exhaust port on a different jug to see if it takes advantage of the lower RPM range. Where a kit like this might shine is if you're a parent getting one for your kid. You got a kid, really wants a motorized bike, but you don't want them screaming down the street at 30 miles an hour, the 49cc is probably the way to go, as it'll probably hit about 20, maybe 25 tops with a lightweight rider after break-in. The only other justifiable reason I can see to purchase one of these kits over the larger ones is fuel economy. It sips fuel out of the tank and should hit 50 miles per tank no problem, but if fuel economy is your only concern, the 49cc 4-stroke is probably a better option, given the frame limitations. If you absolutely have to have one of these kits, then so be it, but that's the only advantage I can think of. To repeat what I said earlier in the video, if you're getting one of these kits for legal reasons, you're overthinking it, as there's absolutely no way to tell the difference without disassembly of the motor. So a sticker might be your better option than getting one of these anemic little motors. So we got a few things we're going to try on this kit. First, we got to match the head gasket to the cylinder. Probably going to deck the head, modify the exhaust, tune the carburetor, and let the break-in period set in. By then you should be able to see this thing doing a little better, but don't keep your hopes up. I'm also going to try another jug with the widened exhaust port, but I'm going to keep it lowered, as was from the factory, to take advantage of the lower RPMs that this thing has to offer. That's all we got for today, and until next time, ride safe.